Hi, we are Team 9 and our project is about automatic boarding pass issuing system using face recognition. And these are our teammates and these are the contents. Coming to the introduction, face detection is currently one of the highly used detection system which finds its application in various fields including video surveillance, authentication systems, security systems, virtual and augmented reality. The task of issuing boarding pass to the passengers at airports can reduce boarding time and avoid physical contact. And this is the block diagram you can see here. And initially the features of the face are captured using a camera or a sensor. Then they are trained by LBP and HOG. These are then classified using a SVM classifier, then detected using the face detection technique, and onboarding is done. Classification method. The important step in face recognition based systems is to generate an efficient classification model. The proposed system is generated through SVM classifier and these LBP and HOG features of the training images. Using the OpenCV, we are using this like it is an open source computer vision and machine learning software library. Face detection steps using OpenCV. Yeah, you can see this image. Then I'll be explaining you the steps like uh, first we have to take an image and then we need to create a cascade classifier which will eventually gives us the features of the face, and then by the use of the OpenCV we will read the image and the features file. So at this point, what the NumPy arrays at the primary data points. So we have to do is that we have to search for the rows and column values of the face, NumPy and array. This is the array with the face rectangle coordinates. And in the final step, we are it involves it like it displays the image with the rectangular face box. Local binary pattern. It is a texture operator which labels the pixels and converts the naming into binary numbers. It has further been determined that when LBP is combined with histograms of oriented gradients, a HOG descriptor, it improves the detection performance considerably on some data sets. The steps of the LBPH algorithm, like radius, neighbors, grid X, grid Y, training algorithm, applying the LBP operation. And this is the image you can see. Like suppose if we have a facial image in gray cycle, then we will get the part of this image as a window of 3 into 3 pixels. And also it can be represented as a 3 into 3 matrix containing the intensity of each pixel. And this value will be used to define the new values from the 8 neighbors. For each neighbor of the central value, like it will be a set of a new binary value, and this one set for values equal or higher than the threshold and 0 for values lower than the threshold. The matrix will contain only binary values. We will ignore the central value and we need to concatenate each binary value from each position from the matrix line by line into a new binary value. And then we convert this binary value to a decimal value. Then the central value of the matrix will be the actual pixel from the original image. At this point, the procedure is done. And the histogram oriented gradients, you can see the image like the image is generated by using the grid X and grid Y parameters to divide the image into multiple grids. We can see in this following one. Performing the face recognition, like what exactly we do in the step is like the algorithm is trained and each histogram created is used to represent each image from the training data set, and then the new image will create a histogram which represents the image. This is the GitHub reference we have done. Web page. And coming to the web page, this is the web application we have created, namely Boarding Pass, where we have a scan button. When this button is clicked, it reverts to the camera, which captures the face and shows the output image with the accuracy percentage. And these are the results, images that we have obtained. And you can see here, we got the maximum result. We have took 3 images. And these are the references. Thank you.